Okay, so I'm going to be talking about a surface development question. So this is a adapted question from Anderson's book, and I'm going to just develop surfaces A and surface B, and I'm going to be using the rabattement method. Students would be able to use a cone to find true length of the line, and then use triangulation if they like. That'll be a method you'd use if you wanted to develop all the surfaces, or you could just use the rabattement method either. Personally, I find the rabattement method is easier for students to understand, especially because it's a lot easier to make a model to fold down all the sides, and students can do that themselves at home very easily. Principles are a lot more simpler compared to the cone method. So the question that I've taken this from is this question here. This is in Anderson's book, but there's actually a mistake in the question, because this surface here, which is surface B, is inclined. Our plan view of our transition piece here won't actually be a rectangle, because the plane is inclined, and the width is given at 30. Sorry, because the plane is inclined, and our line here is shown that it's at 45 degrees is where they're meeting. We'll have to draw an end view here, and that'll give us our point on this back edge, and it'll actually be drawing something similar down. And I've drawn it out here, and I've shown how I got my points. So this line here was drawn at 45 degrees, and there's a ducting attaching to this, so this is a transition piece. Originally this is a rectangle, but that can't be correct because surfaces B and this surface here are sloped. So we take that point, bring it over to our end view, drop our points down where they meet surface B, and the surface here we'll call it C, back down to the XY, and bring it across, and that'll give us the actual shape that we're going to see in our plan, which is more parallel, or just a four-sided shape. So I'm going to go on now and actually develop surfaces A and B. So I'm using the rabattement method here, as I said before. So we're going to be folding A down, and we can see the true length of A in our elevation, because this line here is perpendicular to the XY in plan. That means we're seeing it as an edge view here. That's going to give us an edge view of the lamina A, which is a true length line. So we can fold this down, pivoting around this point here, and bring it back down to plan, and that'll give us the true length of our surface. And we can bring our points back out, and that'll give us the true shape of surface A. Go on then to develop surface B. So this point here on A and B, it shares the same point on A and B. So we already have the point for one of our heights, so we can bring that around using the rabattement method and continue it on, so we can get the top point. But this point here on surface B and here, we have to use an end view to find that point, or we could possibly do a horizontal line in elevation, drop it down, and work from there. But it's easier just for the students, while you're already using the rabattement, to continue on with rabattement. So if we bring our point across from our elevation to our end view, and that means we're seeing in our end view we're seeing the true length of surface B. If we rabat that point down and bring it across at 45 degrees, continue our line down here, and where they meet will be the point for the true shape of surface B. We can then go ahead and draw in our surface B. So I've just gone ahead and taken out all my working lines here, just so you can see clearly the given answer and the question. Thank you.